Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. Welcome to Happy Path Programming. Oh, it's a beautiful day in Crested Butte, Colorado.
Yeah, it's just cold again.
Cold, but gorgeous. Some fresh snow and awesome. So we're going to dive right in. We have Steve. And Steve, I've never met you in person, which would be fun to meet you in person somewhere, someplace, sometime.
And how do you pronounce your last name?
Manuel.
Steve Manuel. But we've interacted on Twitter a bit, and every time I see stuff from you, I'm like, oh my God, Steve gets it. Like he gets it. He gets the Wasm stuff. He gets the now MCP stuff, and just always impressed with the way that you talk about these things, that your mental model of the world around a lot of these things. So I was like, MCP, awesome. Wasm, awesome. Bringing these two things together, super awesome. And so let's get Steve on to talk about that. So welcome, Steve. Great to have you. Yeah, give us an overview of who you are.
So Dilipso is your company?
Yes, Dilipso is a company.
Okay.
By the way, I've been a long time listener of the podcast. Thank you guys both for all the work you do here. We started Dilipso a couple of years ago, and we focused on WebAssembly technology to try to bring it to a larger developer audience. You know, if you've tried to use Wasm in the past, maybe before some of the frameworks that have been out, one of which we built called Xdism, it's a very low level technology. It's primitive in the sense that you only have access to numeric values, and you're effectively managing memory and passing pointers over a guest host boundary to communicate. And Wasm is this kind of shared nothing environment. So you got to copy everything into the virtual machine, then let the WebAssembly code work with it, and then allocate memory, and then pass back that pointer to the memory on the host. And
this would be for like integrations with Wasm programs, essentially.
Yeah, exactly. If I want to execute WebAssembly code from inside my environment, I need to bring something from my environment, like data, into the virtual machine for it to be executed inside of Wasm, and then find a way to get it back to the host for follow-on execution.
It's kind of like the old days of programming Unix in C, where you pretty much have, well, it's not assembly, and it's not no operating system. So yay. But the kinds of things you had to do, and I didn't really understand it very well when I tried to do it. I had no idea what it was doing. So this feels like, okay, we should now have, and that's my first question is, the last time we interviewed somebody about Wasm, there was a whole bunch of things that were gonna be there, like to make it more of an operating system. So where are we now?
Yeah, that's a great question. There's still a lot of things that are kind of floating in the ether of, is it preview status? Is it like production ready? Is it in the spec? Is it going to be a spec? Is it a standard? The good thing is that there's so much activity and still a bunch of energy being put into these specifications that ideally become standardized so that everybody on the web and then everybody outside of the web can use the same interfaces everywhere. But standards take a really long time. And the true original single standard that today is widely adopted everywhere is called WebAssembly core modules. And WebAssembly core modules are the things that run in your browser natively, and the thing that run inside of any WebAssembly runtime outside of the browser as well. Xdism has adopted that standard and builds layers of abstraction on top of it just to make it easier to use. So instead of managing memory and allocating it on your own, we kind of have a set you up for success, easy mode of like just passing strings or JSON over this guest boundary, because it really shouldn't be hard to share a string.
And in that case, so with the browser primarily supporting that core model of WebAssembly, when we start adding layers on top of it, like we'll get into WASI and component model and stuff like that, does the browser have a way to support those, or do we have to wait for the browser to add support for those additional things beyond the core model?
Today, you just use shims like you would in any other kind of older browser that doesn't have support for some kind of fancy new standard or thing that's adopted. And so they are there, except for things like TCP. I'm not going to be able to ever really make a socket connection out of the browser. We'll virtualize it and pretend like you're getting it and spin up a WebSocket in the browser proper. And then to you behind an interface, virtualized is read data off of a stream,
Yeah.
which once compilers for most languages get there, then you can just write the normal socket open function, and the standard library will pretend like you're calling that system call. But in reality, it's some virtualized layer that's actually hopping into the host outside of WebAssembly and then talking to some WebSocket stream and then proxying it back and forth.
Yeah. So so what you're doing is you're building XDism as kind of a layer on top that I can program to. Now that's starting to sound to me like an operating system.
Totally.
And so I guess even if or as WebAssembly, the WebAssembly becomes an operating system, you will simply adapt to that. And so if I were to start using it now, I could continue using my code isn't going to break because you're almost creating a container.
Don't say that word.
Don't say that. Oh, sorry. Don't say that word. You're not creating a container. Strike that from the record. Okay. But you're creating...
It is an abstraction over this like runtime.
Andrew Koenig once told me that all problems can be solved by adding another level of abstraction. So that's what you're doing. It sounds like. And and your goal is to make it so that I don't have to think about all that stuff.
Exactly. When I first saw WebAssembly almost 10 years ago, like to me, because of the design intentionally was not to be bound to the browser. It was always supposed to have this agnostic environment design. It was a compile target and it was isolated in its memory access from its host environment. To me, having written a bunch of plugin systems in my life was like, that is the ideal plugin system for everything.
Yeah.
And so immediately I knew I want to build plugin systems with WebAssembly. And at the time, there really was no way to run it outside the browser. So as soon as the language of choice for me at the time was Go, when Go added the syscall.js package and was able to compile to WebAssembly, I had this project that I could experiment with, which was called Protolock. And it was this protocol buffer API compatibility kind of linker. And I was like, great, this is a command line app, but I should be able to compile this thing to Wasm and run it in the browser so I could host a demo and show people, throw in your protobuf file, lock it and snapshot its state, and then change the file in the browser and then check if the protocol buffer is the message.
So Wasm-based IPC in the browser to get to your plugins that you had dreamed of.
Exactly. And so it just worked. And I remember this moment so vividly that like the output from what was otherwise flushed to the terminal was in my browser console. And I was just like, stop. Like, what is going on here? And this is 2017, maybe 2018. And at that moment, I was just hooked. I was like, I have to go super deep because I don't know what's going on here. I need to figure it out.
But you saw this like opportunity for Wasm to be this foundation to really address some of the issues that we have with how we take things and bring them together.
100%.
And what is your language of choice now?
Right now, I mean, if I have all the time to tinker, it's Zig. I'm a big fan of.
Oh, nice. We got to get the Zig. We do folks on. Yeah,
they're a great team. I'm incredibly impressed with how much they're able to do with the resources they have and the members on the team.
And good Wasm support and Zig.
And great Wasm support. That's kind of the initial draw for me.
That's awesome.
And then if I'm not able to do Zig, it's Rust or Go. And we have a pure Java WebAssembly runtime called Chicory, which has kind of reignited an interest in the JVM languages for me.
Okay, so Chicory is a JVM essentially implementation that can run on Wasm.
It's a kind of the reverse of that. It's actually it's a WebAssembly runtime that executes natively inside the JVM and loads WebAssembly code and either interprets it or AOT converts it to JVM bytecode.
Oh,
so you
cool.
can run Wasm at native JVM speeds and get all the same benefits of all the things that the JVM provides you from observability and memory management and all that stuff. And that has kind of reignited a interest in exploring the JVM language landscape, which has been off my radar for a very long time.
Yeah. But a lot of this, your driving like mission in a way is how do we take things and get them to talk together more efficiently, more easily across language ecosystems, across, all sorts of different boundaries and challenges that we've had in the that space of
exactly
IPC, or I don't know what the general term
I have had
for
that dream since I was being started in this world, which is that you should be able to write a thing in whatever language is best for that, and then the other pieces should be able to use it regardless of what language they're written in. And this seems like, and also the cross-platform stuff.
Mm-hmm.
It's like, okay, here we finally have something that the different vendors can't go, oh well, you can only do this in ours, or it's going to be hard to. Oh man,
yeah,
exactly.
So you saw the opportunity for Wasm to be the foundation for solving this problem in a new and much better way.
And what state is it in now? What state is your product in now?
We have lots of people using it in production in incredible systems, things that I would have never guessed. Like, for example, 1Password sharing portable code inside of all of their clients, leveraging Xdism to convert code written in Rust, compile it to Wasm, and share it inside of Go, JavaScript, PHP, Python libraries. Kind of just the purest, perfect use case for WebAssembly.
That's awesome.
And we obviously use it in all of our products. So we have a kind of commercial product for bringing plugin systems into your SaaS. We've always kind of thought that WebAssembly was the plugin system use case, and plugins were largely forgotten since the web kind of became the main distribution platform for software. But I grew up writing music and working inside of these digital audio workstations, and so VST plugins were things that I just knew and loved and could bring around different DAW systems with me. I was like, why don't we have this for everything? Why can't I literally take some code I wrote for a WordPress site and run it inside my other CMS blog platform? It's like the boundaries didn't make sense to me, and I thought there should be something better. So largely we wanted to make all software extensible. And
composable at runtime is what we're saying.
Dynamically linking. That's why we named the company Dilipso.
It's all coming together.
Dynamically linkable, safe, high performance way of bringing all kinds of code together and making it work together in new ways. Just the way it should happen.
So dynamic library shared objects, something like that. Okay. Exactly. And what's Xdism?
Xdism is the framework that makes it easier to compose these pieces.
Right, but how did that name? How did you create?
That's like extensions and Wasm.
Okay. Well, that's very
oh my God, I love
good. Nice on the nose names.
So the vision was let's compose these things at runtime together, and you've built a bunch of different things to make that easy. Are we ready to transition to component model and WASI, or do you need more setup to get there?
Yeah, no, absolutely. For folks who aren't aware, the component model is an effort to try to standardize the way that all these Wasm languages can interop and allow you to define new interfaces to kind of plug Wasm code into all kinds of other contexts. And so the Bytecode Alliance and some other folks in the ecosystem are working towards an effort to get these specifications standardized through the W3C. But today, the W3C maintains the spec for core modules, and the component model is working towards getting standardized.
Okay.
And WASI is in this kind of weird, it's component model, but it's not. WASI Preview 1 was the first incantation of this that actually felt more like POSIX libc style, kind of fitting into today's software. And then WASI in its next versions, P2, which is today, and P3, which is coming at some point, is really like a complete rethink of the computing platform. So it's like not Unix, POSIX. It's let's rethink everything from the ground up. And unfortunately, I believe that means everything has to go to Wasm for it to really work and proliferate, as opposed to what we think is the right approach is let's bring Wasm into the world of software today and make it interoperable with this massive ecosystem of
That's a more practical approach. They're saying, hey, we have the opportunity to fix a lot of the problems that we have encountered. But I like your approach because it means that I could do this now.
Correct.
Even while they're developing the platonic ideal of an operating system.
Exactly.
So what is your, I got to ask this because I've been a Python fan forever. What is your Python story?
Somehow, I honestly do not have a Python story.
You don't.
It is the absence of a story that might be
like you don't know the story, or like maybe there is one and you just don't know it, or there isn't one.
I somehow have avoided writing Python almost entirely my whole career. But
there is Wasm stories for Python, and
we support Python. Do you mean my personal story or Xtism?
No. I meant for Xtism.
I'm sorry.
Am I saying that right? Xtism?
Xtism. Yes.
Xtism. Yeah. See, the ASM. I want it to be ASM because it's for Wasm, but you're saying it's Xtism. Okay. Anyway, so I can use
Python. Of course, we support on both sides. You can embed Wasm code through Xtism inside of your Python applications, running as the host environment. And you can compile Python to Wasm to run inside of any other host that can load WebAssembly code.
Does that constrain the kind of Python I write?
It does, yes.
It does.
Practically anything with native modules that are compiled from C to a shared library and running inside of Python that's dynamically loaded is more or less off limits for now. There are efforts to make that different, but today it's a challenge. And then,
so this is real quick. This is like you have a way to do essentially FFI in either direction. Yep. So if you're in, let's say, the world of Python, you can embed Wasm essentially, and then call that Wasm from the Python side. But you can also go the other direction, and you can take Python, turn it into Wasm, and then call that from wherever as well. But and so you don't care like which direction you go in the FFI essentially world, but and Wasm makes it all work.
But there's certain things that are very dynamic in Python that would seem like might be off limits for a compiler. Is that right?
No, 100%. And
okay.
The trick with Python and also with JavaScript and also when we do Ruby and PHP is that an interpreted language, as dynamic as they can be, cannot, without a substantial warm-up or kind of partial evaluation process, get to instructions that map to the Wasm instruction set. So you're effectively compiling the interpreter, and then you're running the code inside of a Wasm module inside of the interpreter, CPython, for example, or JS.
Isn't that how like Wasm in the browser essentially worked, at least in the early days? Like they were like building this Wasm interpreter on top of the VM of whatever the VM in Chrome is. I forget the name of it.
Yes, yeah, exactly. And so in V8 and
V8.
Turbofan and other processes that run to actually take JavaScript code and compile it to bytecode that's executed in the browser, the Wasm code was executed in interpreted mode first. And in fact, I think there was even a conversion to JavaScript that really, really early on was, obviously not
remember that
long-term strategy.
Yeah.
But yeah, there's an incredible history of hacks that made WebAssembly possible as they iterated on the early spec and implementations. But today, both JavaScript and WebAssembly in the browser are JITted for the most part. So you start with the bytecode for Wasm or the text format for JavaScript, and then a bunch of different compilers start to go at the code and turn it into native code that executes on the architecture that the browser is running on, ARM or x86.
So in the easy kind of first pass approach to interpreted languages is you basically just run your interpreter in Wasm, and then that can take your language and run it through that interpreter. But the more ideal, which the browsers have already done, or at least Chrome has already done, is to then have a native interpreter for the language, so you don't have to go through that. Like have the interpreter actually running in Wasm. Was that?
Well, the interpreter does run in Wasm, and that's the way. That's the kind of hack, easy way to do it today.
Yeah.
Ideally, there are ways to precompile the dynamic language to Wasm instructions directly. But in order to do that, like you need to know what this number in JavaScript is equivalent to, the I8, 16, 32, 64, whatever in Wasm to actually truly have optimized code executing in the Wasm runtime.
Yeah.
And for lots of reasons, that's just a really difficult thing to do.
Yep.
So
you end up writing a JIT essentially for Ruby, a Wasm JIT for Ruby, and that's probably a monumental lift.
Yeah, there are really impressive ones that exist already, and shout out to Shopify with the YJIT project for Ruby.
Huh.
The problem with doing JIT inside of Wasm is that once a Wasm module is instantiated, you can't change the code. And I say that's a problem, but it's actually a feature that keeps the code secure.
Yeah.
And so JITting inside of Wasm at runtime is likely not a possibility. And maybe there's some change in the spec in the future, but today the code is effectively immutable once it's started.
Which sounds like a good thing.
That's not true for the compilation step. So when a Wasm module is instantiated, it does get compiled, and then that compiled code can be JITted and optimized in the runtime. That's actually happening in the host as it then executes that WebAssembly code.
Yeah.
But yeah, having a JIT from like a JavaScript engine inside of a WebAssembly module, we can't do that yet.
Yeah. So will it make sense? I mean, I guess the general question is, is Wasm everywhere a possibility? Like, say, Wasm on the desktop without the browser?
Sure.
Will I be able to have a Wasm support in my single, my Raspberry Pi, whatever? You're nodding. So you're saying this is true, like it could become the universal operating system.
Largely, I believe it already is. I think, the work that we've done and other projects with XDism alone, you can already do the kind of write once, run anywhere approach. It works in the browser. It works in the desktop standalone. It works embedded in other software in 16 or more different languages. It works at the edge onside a Cloudflare worker. It works on a watch. It works on a phone.
It really has become the universal bytecode.
We should probably insert something here because write once, run anywhere is probably trademarked by Oracle. So we acknowledge their potential trademark.
Yeah.
Yeah.
Okay. So real quick, back to component model and WASI. So we've got the core Wasm stuff, and that's all great. But at least in the desired world that we live in is how do we bring these things together? The component model gives us the right kind of machinery and ways to define how we do that. From what you said, there's kind of two different approaches to this. One is, greenfield, where you just imagine that everything can be a Wasm and yay, now it's all easy and you can take Python and turn it into Wasm, Rust and Zig and turn it into Wasm, and those things, great. Once you're all in the Wasm world, things are easy. But then there's the other brownfield world where, I've got a bunch of JVM servers and I want to be able to have these same kind of benefits in the JVM, but also pulling in some Wasm modules for different pieces of functionality.
Right.
And does the component model in WASI give us kind of the composing of those things for both of those worlds, or just on the pure Wasm side?
Eventually, I think it could do both of those things. The component model, I think, in a pure form, is really all about how do I take a bunch of different languages and compile them to a bytecode format that can be linked together and know how to send Ruby types to a program running PHP and standardize a conversion between them to interoperate across language boundaries, so that you can then glue together a bunch of code that was written in different languages as one kind of static module. And then in some other program, load that thing that, aggregate of C and JavaScript and Rust and PHP and Python and whatever.
And it's just invisible. The modules have this universal interface, so you don't know what language it was written in.
Ideally, yeah. And unfortunately, though, still in the JavaScript or any of the dynamic languages, you're going to have to jump into an interpreter, and there's all this complexity there. And so, like, I personally, I hope to be out of software by the time any of that actually lands, because I don't want to debug something that is a combination of PHP and JavaScript and Rust and Go and Zig, and having to try to find a trace that spans all of those language boundaries, because everything still has their own stack, and everything's unwound inside the language boundary. And there are specs that are trying to solve for all these things, but it's a
complex space.
It's a crazy complicated thing to solve. So,
real quick, go into WIT.
Yeah.
So
WIT is the description language that says, hey, forget about what you want to think of this thing in Ruby as a class, or you want to think about it as a object in Java, class in Java, or a struct in Go. It is a WIT type, and it is a abstraction from largely like drawn from Rust's type system to describe types, function signatures, and values that then get generated into like the boilerplate library that represents those types inside of all the different languages. So the kind of
this becomes like the shared model that then allows for two different WASM modules to then have a common model of
so
interaction.
Presumably every language is going to have its WIT module or whatever that you can create these things with, and it'll convert them to this common language. Yeah. Okay. Yeah. I do want to know, is there an effect story for WASM?
I do want to get into that, because I think that's a fascinating one. But there was one other piece that I wanted to follow up on, or two, real quick. Okay, if you're embedding WASM into, let's say, a JVM, would you use WIT and the component model or in WASI to create the bridge between essentially the FFI between those two things?
Today you can't, because there is no runtime that works in the JVM that supports the component model, unless you want to kind of break the sanctity of the JVM and link, a Rust shared library. Wasm time is the only runtime today that supports component model. And so you would have to compile that into a shared library and do FFI yourself, and then write the bindings in JVM. And then you can take you can call a component owned function from Wasm from your Java code, but it's not easy to do today. So if you want to do that, we have a Chicory SDK for Xtism that makes it easy and native and just runs as a library inside of your JVM app.
Gotcha. Okay. So at least the state of the runtime, the embeddable WASM runtimes today, maybe we're not quite there yet, but with Xtism, there is a way to do essentially this shared modeling model sharing across this.
We should have a developer retreat on using Xtism.
Yes. Oh, that'd be fun.
Do it.
Will you
fly
out? Will you? Okay. We can put you. I have a pretty nice guest room we can put you up in, and
all right, sign me up.
And you can record the whole thing and put it up on YouTube.
Okay, last follow-up question, and then we'll move on. What's the story around distributed systems? Because I think generally what in this world that we're talking about, it's like a single process is the boundary. But it seems like, hey, maybe I could take this WIT definition and now have a way to have a distributed system where I'm talking over a network boundary instead of in process.
Yeah. There are a couple projects, one of which is by a team that builds a kind of WebAssembly cloud platform called Wasm Cloud, and they have a project called WIT-RPC or WRPC, which is kind of a distributed version of communicating across that abstract type definition boundary. And then another company called Fermion, which builds a similar kind of cloud platform for running WASM code inside your Kubernetes infrastructure, has a project that I'm blanking on the name right now, but it's similar in the sense that you get to kind of call a function over
remote
the
wits,
it's a
remotable
remote
wits. Yeah,
exactly.
that's not the name of it, but something
Yeah,
along those lines. Cool.
correct.
Okay. And then Bruce mentioned effects, and I want to come back to this piece. So it seems like the component model on WASI, and I think Golem Cloud kind of gives us some indication that having Wasm, having the component model, having WASI allows us to manage some things in ways that we've never been able to before. With I can then know what this particular piece of a program is going to do in terms of side effects, and then I can have a runtime around that, manage and deal with all of the complexities that come up when we get into side effects.
Yeah,
Give me your perspective
absolutely.
on that.
On its own, WebAssembly in a standalone environment without WASI or anything around it can't do anything besides compute. It's just pure logic execution. And you use then imports as defined by the spec to give that WASM code a way out. And so it's kind of like if I want to peek out of the little sandbox that WASM has for me, I'm going to use an import, which is provided to me and implemented in the host and abstracted at the WASM module level. And the WASM code can call indirectly into the host through those imports. So that's the only way to get side effects in WASM code. And all of those are inspectable before you run the code. I mean,
Love
in
that.
fact, you can't even instantiate WASM code unless all of those contracts are explicitly met. So if it doesn't have at runtime that function that gives it access to go and read some socket, the code won't instantiate.
Yeah. And dynamically weavable in some way. So I think I've seen demos around this. I love this idea of when I'm working on my local host in development, I want to just write my logs to standard out. And so there would be a binding of I've got this logic that needs to write to standard out, and I have linked for development time that to my actual standard out. But then when I want to take this WASM and run it up in the cloud, I don't want to write to standard out. I want to write to the cloud logger. And
Right.
you can then rebind essentially that import or the implementation of the import, so that then transparently, without the developer having to change anything, my logs have moved from standard out on my machine to the cloud logger. Am I understand some of that correctly?
Absolutely.
And that's some of the like awesome thing about being able to know what the side effects are, is that then you can switch these implementations.
Right, and when you're dealing with multiple languages, well, how do you report errors? Some of them have exceptions, some of them don't. You are almost forced to go to errors as values, because how else are you going to know? It's almost forcing. Oh, yeah, it's really almost forcing.
It feels
effects.
so compatible with
It
functional
does.
programming, and
Yeah, because I want to call a function on another module, and I have to pass it this, and how do I know what I get back? And it would almost be a good little section in the introduction.
Yeah. And then this is actually a good bridge to our next topic, because once we know about the potential side effects, then the thing that's running this thing can then manage those side effects and be like, oh, you're trying to do this. I'm not going to let you do that. And now meet the world of MCP. So
that's right.
Which let me start by just saying, I finally started remembering it because of Tron and the master control program or whatever it is. And so I'm going, okay, that's how I remember MCP. What does MCP stand for, and what is it? So for listeners,
MCP stands for the Model Context Protocol, and it is a standard released by Anthropic that covers a few different things, but probably for this conversation, it makes sense to focus on tool use. If you have an AI application, LLM, something like ChatGPT or Claude Desktop, you're typing requests or messages to it, chatting with it, having it distill some knowledge and then respond. There are eventually things you want it to do that aren't just based on the knowledge that the model has at the time the model was cut and then released to the world. Those are things like talking to, like, their effects. They're the side effects, where the model on its own is just the clean code
not able to have side effects.
And the side effects are the tool use. How do I go and reach out to the internet and do a Google search? Or how do I let AI read a document and summarize it and then do some follow-on work about what that document had inside. So it's just giving new capabilities to an AI system that expand beyond the model's knowledge that it was trained and kind of cut to then released to the world.
And
so
we've seen this primarily adopted at this point within coding assistants, because I've got my coding assistant, and awesome, it can write code for me. But wouldn't it be nice if it could talk to my issue database, and I could be like, hey, coding assistant, go find an easy issue in my issue database, and now just handle that, right? And so one of thousands of different ways that in our coding assistants we may want to connect to external systems. And so that's where we've seen the explosion around MCP. But then there's the broader, I think, more useful piece of MCP is, in the future world, there's going to be lots of agents running in lots of different systems, and being able to have a standard integration protocol for all those agents is world changing. So anyway,
So we had been working on some kind of demos to showcase our first commercial product, was called XTP, which is that SaaS plugin system for everybody. And one of the ideas was, could we do universal, portable, and secure function calling for AI? Because we thought it was silly that every AI agent framework was saying, oh, you're in TypeScript, you got to use a TypeScript tool to let your AI agent go and do a Google search, or to read your Gmail, or to whatever. And a Python AI agent could only use Python tools. And we're like, well, we just know that's not true. Like, we've been doing this cross-language stuff for 2 years, and like, we know that's just wrong. So
this is all like driven by back to your initial like driving force was, you wanted a plugin system for AI, and MCP emerged, and you're like, cool, now we have the specification for this plugin system for AI.
Exactly.
But do we have the security? Do we have the side effect management? Do we have all these other things?
Right. So day one, when Anthropic released this, we had done like just maybe weeks prior an analysis of that demo. Could we do this and deliver something interesting? And what we learned was there's just too much fragmentation in all the different models, the frameworks, the providers, for how they describe their tools. Some people want it in JSON schema with these fields and these parameters. Some people want it as a totally different specification. So we ended up realizing we'd spend all of our time writing the adapter code to translate between those things. And we're like, we're a small team, we're a startup, we can't afford to spend all that time doing this. So we put it on the back burner. And luckily, just weeks later, Anthropic dropped MCP. So that was the missing link. Now let's go and do this. And as we started to investigate, we were all just like totally floored what you could do with giving tools to a AI assistant or chat application, and just thought like, this isn't just a cool way to show off our technology. This is like an internet scale paradigm shift in how systems and people and applications interact. And thought, if we care about plugin systems, and if we think AI is going to be in every piece of software, then this is the AI plugin system. Therefore, it is the only plugin system that actually matters in the future. So let's just go all in and build. And at that time, it was really just Claude Desktop could kind of consume MCP servers and connect to things, and Claude could chat with your email, and like, that was cool, and that was really compelling. And then you're right, now there's been this huge draw in developer tools, because my IDE can now be infinitely extended with all of the tools and things that I use day to day, that I would have to leave the IDE to go jump into Linear or Jira or GitHub or Slack or whatever. And now I can all just drive it inside this command center, which is my IDE.
Your AI coding agent. Yeah.
I'm very excited about this.
Yeah. So then you, as part of this, you're like, oh, we could have a way to pull Wasm and MCP together.
Right. So the initial implementation and release, which largely was like demoware, was download a npx script and run it on your machine and give that thing to AI wholesale. Yeah. Anything you can do as a user, that npx script can do as a user. And it was a one-to-one mapping of a new process for every MCP server that you wanted to spin up. So we thought, security, yikes, I'm not going to give dynamic access to my machine through npm loading scripts off the internet,
and potentially having the LLM like decide what commands to run, which could, it could hallucinate something catastrophic on your machine.
Absolutely. And the problem of just like spinning up a whole process for just like one little tool call just seemed like this is a great way to deliver this right now, but I can't imagine having 100 processes all the time just,
it's not
running.
going to scale.
It's not going to scale. So we thought, why don't we just deliver one MCP server that could be dynamically reprogrammed with relinked Wasm servlets?
Right.
And very early on, James actually made a comment in our Discord being like, guys, don't use servlets. Out of all respect, we probably should have changed the name at that point and listened to you. But,
it's just my PTSD with 20 years ago in the Java space. So I'm past it. I feel better now.
Good. And the side effect of using Wasm for all of this is that we get to bring all of those security benefits. It's not just about reducing the load and overprivileging code that gets handed off to AI. It's that when you install a Wasm-based server, that you have to approve, at least on our system, which domain names, which hosts it can connect to. So I can't exfiltrate data to some foreign server when I meant to just talk to GitHub. Because these MCP servers right now, it's the Wild West. It's like they're implemented by anybody. They live anywhere, and they do anything
they want.
Program can or computer can do.
And anything they'll may instruct them to do. So the fascinating thing about Wasm here is that you get all these things for free. You get the sandboxing of the Wasm, you get the side effect tracking and management, you get a component model for integration. Like it just seems like this is just peanut butter and jelly. I don't know. It's just such a good fit. I love it.
I totally agree. I completely agree. And the other benefit is portability. So when this all first started, where Claude Desktop was kind of the first thing you could load extensions and MCP servers into, everything ran on your machine over that standard IO transport. And there was a second transport called SSE, which enabled remote connectivity between the AI application and the tool. And because we're in Wasm, everything on our platform, mcp.run, is Wasm based, and therefore we immediately could just switch on remote connectivity one-to-one. So if you previously had used standard IO and were running these things locally, you could just decide to change, and we'll host and run all that stuff in our cloud, and it works exactly the same because it doesn't matter where the code runs. The code is the code.
Isolation from transport. Who cares?
Exactly.
Yeah.
I've been through a lot in my career, and I have come across a lot of things. Like in the 90s, there was the AI revolution. You don't know anything about that? That's because it didn't happen. It was all marketing hype. This is the first time, well, not the first time, but I mean, this seems like it's like, I feel like this might really go somewhere. This feels like it's got a lot of
for the first time
technology.
We have a plug-in model for AI. And that's I think the revolution that is people are getting pretty excited
So do
about.
you think Anthropic used AI to design the plugin model? I mean, I would.
Possibly. I mean, a shout out to their team, to David and the folks on the MCP team there. They're an incredibly smart group of people. They've seen a ton of software. So it wouldn't surprise me if they didn't. But, who's not sprinkling a little AI in here and there?
I try, one of the things that has changed me is that it's pointed out how little I ask questions when I should be asking questions, how quickly I jump to conclusions. Sure. And now I'm trying to get myself to go, hey, let's ask the AI and see what it says before I go, oh, this is obviously the right way to do it. And it's taken me down some rabbit holes, but even those have been useful. It's like, oh, sure. Now I understand this. I don't know. It's really changed my perspective to one of more curiosity and less the way our brains are wired to jump to conclusions.
Totally agree.
Yeah.
So is there a connection in what you're doing with MCP.run and Wasm stuff to the component model in WASI?
No, not at all. Okay. We've built basically a complete alternative that has just as much support, interoperability, and availability and portability, because we want to deliver all these things today and not wait for what might be years until standards are like locked in and say, great, cool, you can do it. And there's plenty of implementations available and you can run components everywhere. We're just not willing to kind of wait for all of that to
Gotcha.
settle. We can build it ourselves.
you've built it in such a way that when the component model and WASI are readily available in runtimes and in the browser, like this stuff isn't even available, like an actual WASI and component model isn't available in the browser yet, right? So
WASI P1 is, and you can technically run components in the browser using a tool called Jcode, which basically rips apart the component and turns it back into core modules, and then runs those core modules inside the browser.
But if I'm using your tool, I can work now and not worry about it's going to change underneath and all that. I can just say, oh well, I'm just talking to this thing, and they're doing the underneath adapting, and as it gets better, they'll get better, but my code isn't going to break.
Yeah, exactly.
That's pretty appealing.
We launched our 1.0 in like January of 2023 or something. So we've been stable for a very long time, with the intentional choice of saying, let's simplify this down to the minimum you need to have a universal interface, a data sharing model so that it's easy to do what you would assume should be easy, like sharing bytes over a function call. And then have also built a few layers of extraction over that with our tool called XTP, which lets you do a similar IDL-based code generation strategy to get the boilerplate out of the way so that my types can be defined one time in an open API, like JSON schema style format, and then generate code in Go and Rust and Zig and C# and C++ and Python and JavaScript, so that somebody who wants to implement that interface can just use those types and functions without having to know the API themselves and retype all that code.
Yeah. Nice.
Yeah. I'm intrigued. Yeah. Very intrigued. I feel like, this is something it would be nice to get a group of people together and experiment with.
Yeah.
Let's do
super
it.
fun.
Yeah. Well, right. We'll see how many people respond.
Yeah.
Who say, I'd like to do that and create an event.
That'd be fun.
Yeah.
What do you see on the horizon?
I think that this is actually not a developer technology at all. And so just because developers are usually the early adopters, they see shiny new, they're like, cool, let's tinker. And that's awesome. But it's also really kind of narrowed what the applicable scope of MCP in particular is to, it's an IDE plugin system to make my tools available to me in my development flow. And in reality, this is actually a massive unlock for productivity for every person, not just technical folks. So you can imagine an AI system being able to stitch together on its own my Salesforce and my Slack and my email and my calendar to basically plan, invite, coordinate, propose, engage with prospects and all kinds of things you do day to day, research, and on its own, take a prompt and in natural language understand that you as a user want to read my recent emails, make sure those contacts are in Salesforce, schedule time with the ones I haven't touched base with in less than 3 weeks, and send an email to those based on the context you have in that Salesforce object.
Yeah.
Just as if I would send that email to a colleague, the AI can pick apart that message and stitch together those tools and execute the workflow on its own.
This is my dream, which is that we all get our own personal AIs who know us and know our needs and can talk to the other AIs. And so if I say, I want a new massage chair, it goes, I know exactly what to get you. Totally. And I'll take care of it. And it's looking out for me. And so think about this. We're talking about a world without advertising because it would become pointless. The AIs would go, I know what you need, and I'll do it all for you. And I don't need to know whether I'm talking to Salesforce or if I even have a Salesforce account. I just say, here's what I'm trying to do, and it goes, I can help you. And think about what that means in terms of businesses. Like you're creating a business, you've got a bunch of overhead. What if you could just focus on this stuff? And the AI is taking care of all the bookkeeping and all of the management stuff for you. We don't end up with management hierarchies. This is my dream, is to have an AI.
Well, you can check out, not to plug our product, you can check out mcp.run/tasks, which is this AI orchestrated workflow engine that stitches together MCP servers based on natural language and just does things for you. You get a microservice out of a prompt and tools.
Oh, I gotta check that out.
So we're almost
So,
there.
so this dream of Bruce's, it's powered by MCP and Wasm. Clearly, I mean, is there any other way? I don't.
You know, I mean, there are certainly other ways. We're engineers. We're going to find a different way if we want to.
Yeah.
But this one seems to have a lot of all the things you need in terms of security and portability. Cost is minimal because Wasm runs so efficiently.
The universality of Wasm, being able to run everywhere.
So before we run out of time, we are the Happy Path Programming Podcast, and so we should ask, what brings you joy? It doesn't have to be programming oriented. What brings you joy?
My family and my kids. I've got 2 amazing little kids and a wonderful wife, and if they keep me sane. And work is crazy, and they're just the best part of it. So.
Nice.
And is there any intersection of Wasm or MCP into their lives yet?
My son says, "Dad, did you work on Wasm today?" He's a 5-year-old. He asks me that 3 or 4 times a week, and it's just so funny to hear him say Wasm.
That's awesome.
Yeah.
Ooh.
Awesome. Well, Steve, I know you got to drop. Thank you so much. Super fun, and really appreciate all that you're doing and how you're moving things forward. So
my brain is
fun.
super stimulated from all the things that you say. Yeah.
Let's keep it going. Let's do that Exism Dev Council, and we'll make it happen.
The retreat up in Crested Butte.
Yeah. That sounds pretty interesting to me.
Great. Well, thanks, Steve.
Thanks for having me. Bye.